In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. Question 2, they give us a function here with a couple of letters missing, B and C, and they do tell us though it has a minimum point at 3 minus 1. Now, when I hear minimum point, I think differentiation, and that is how I'm going to solve this question. There is another way to solve it, knowing the shape of a quadratic and some information about this minimum. It's a little more complicated, but I'll throw it on at the end of this because it's very short. Okay, differentiation. If we differentiate this, we would get 2x. This would become just b, and the c would disappear. And at a minimum point, I know this has to equal 0. So if we try and solve this, we'll fail. We're missing an x and we're missing a b. The thing is, we know what x is at a minimum point, and that's what this is at. Because when we're equal to 0, we're at a minimum point. So we just put in 3 for x. So this becomes 6 plus b is equal 0. b must equal minus 6. We're halfway there. How do we find c though? Again, we remember this point, not only is it a minimum point, it is a point in this function. So this function, f of 3, has to equal minus 1. That's what this tells us. When we put 3 in, we get minus 1 out. Put 3 in, we get minus 1 out. Put 3 in, we get, let's do it here, 3 in, we get 9 plus 3 times b, or sorry, 3 times minus 6 plus c. The answer we get out is minus 1. We just solve for c. Let's see, this leave c here, get minus 1 plus 18 minus 9. C is equal to 8. And that's it, that's the answer. B is minus 6 and c is 8. The other way to do this, which is actually it wasn't that long of a question, but it's even shorter again, is knowing the shape of a quadratic. Well, I guess I don't know where the xy axis is, but let's just say it's something like this. I know the minimum point is 3 minus 1. This is the minimum point here. But that tells me that an equation for this has to look like this. X minus 3 squared minus 1. I know the function of this looks like this because at this point, the smallest this function can get is when x is at 3. And this will go to 0. And the number left over will be a minus 1. And that's here. And just multiply this out, we'll get x squared. Let's see, we'll get minus 6x, which is the minus 6 for the b. And we'll get plus 9 minus 1, which is plus 8, which is the c. Part B, we're given this expression with the limit of n going towards infinity, and we're asked to give an answer. And it's actually, we can get an answer very quickly here when you get used to these, but I will try and explain each step as I can. First thing to remember is you can do each of these separate. These are just separated by a plus. That means we can get the limit of this on its own, the limit of this on its own, and the limit of this on its own. So I'll deal with each of these separately. The best way I like to think of these is, imagine a big number put in here, 1,000. Let's say n's 1,000. 1,000 divided by 1,001. Does the 1 really matter? Maybe. For some things it would. What about 1,000,000 divided by 1,000,001? Again, does the 1 matter? Much less. What about a billion? A billion divided by 1,000,001. There's not many things in the world that you need to be that precise for. 100 billion. Nearly definitely doesn't matter. And remember, infinity is so much bigger than all of them. Infinity divided by infinity plus 1. That's what we're dealing with. The 1 is negligible here. Now we can't really divide the infinity by infinity, but if we recognize that the 1 is negligible and we just ignore it, we can divide n divided by n, and this whole thing just becomes 1, this first part. The second one is very similar, except instead of 1, we have 1,000 added on. And you might say, well, 1,000's a lot bigger. 1,000 definitely matters. And it does, when n's 1,000 it does, 1,000 plus 1,000, 2,000 divided by 1,000. It definitely matters, that changes the answer a lot. 1,000,000 though, 1,000,000 plus 1,000, okay, matters a bit. 1 billion, less. 100 billion, a lot less. 1 billion, negligible. 100 billion, trillion, definitely negligible. And infinity's so much bigger than that again. The 1,000 just really doesn't matter when we go up near infinity. So it's just n divided by n, and that again just cancels to be a 1. The last one's a little more complicated, but how I like to think of it is, let me draw it. Here's a box that's 1 by 1. A third of that box, when we a third to the power of n, that's like doing a third multiple times. So a third of this box, let me cut it off here. I've turned the box into the bottom half. That's if n was 1, I'd get this. If n was 2, again, cut this off, a third of this box, we'd be left with this little bit down here. If n was 3, cut it off and be left with this here. If n was 4, cut out here. 5, 6, and that's it. I can't even draw it anymore. If n is just the number 6, I get from this whole box down to this little area down here. If n is 10, I get much smaller again. If n is 100, microscopic. If n is 1,000,000, like calculator, I doubt calculator will give an answer other than 0. So as n approaches infinity, this approaches 0. That approaches 0. The answer is just 1 plus 1 plus 0. Or even write that out, 1 plus 1 plus 0 equals 2. That's the answer to part B. In part C, they give us this drawing of gx, a function, some function. They don't tell us any of the maths about it. This is just what it looks like here. And they ask us, so let me write that in, gx here. They then ask us to draw, let me write gx minus 2. How do we draw it? Well, if this is gx, taking 2 away from every point here is just going down 2. Now they have numbers in their axis, so hopefully you do as well. So this one was at 4, we go down 2 to get to 2. This is at, let's see, 1, we go down 2, we get to minus 1. And so on. We just fill in the exact same shape. Everywhere it goes down 2, that's all it is. That would be full marks there. In C part 2 then, I'll draw it again just so we don't get too mixed up about anything. In C part 2 they ask us to draw a g of x plus 3. When you get used to these, you'll look at this and go plus 3, that means everything moves to the left. So if you're happy doing that, just draw it, everything moving to the left, 3. That's fine. Let's go through why that is a bit by just doing some examples. This point here is at minus 1, 1. So basically, when I put minus 1 in here, I get 1 out. Let me write it like that. G of minus 1 equals 1. Let's see what would happen in this new function if I put minus 1 in. So if I went to the point minus 1, I put it in here, I would get G of 2. And G of 2, I understand everything about G, because I can just go to 2 and see what I'd get out. I'd have to look at their good drawing. I get 3 out. 3. So that means in this one, when I put minus 1 in, I would get 3 out. So when I put minus 1 in, I get something like here out, 3 out. This guy has been moved wherever it should have been. It has been moved over here. And you'll find the same. When you test this one, you'll find this answer. When you test this one, you'll find this answer. When you test this one, you'll go outside the range. So everything will just move over 3. I guess roughly you'll get something like that. Rough drawing. Remember, this one starts at minus 2 and ends at plus 2. This guy should start at 3 to the left of that. So instead start at minus 5 and end at, I guess, minus 1. Okay, Oh, there we go. They should have stopped around here somewhere. Okay, same here. It should be the same length and stop. All right, hopefully that answers that. Yeah, that's the last part. Okay, thank you for watching. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.